Alright, let's begin. So for this video, we're going to be covering the documentation for all my personal project. So to start off, we have the UI. The UI is an updatable, drawable, loggable, and inputtable. This is the class that all my UI components derive from. The drawable for all UI components is handled in the backend. However, if the user wishes to have things happen on updates, alarms, or inputs, they can derive them themselves. There are four types of UI to define. There's the sliders, the radio button groups, the check button groups, and the buttons, which is a subset of all the other buttons. Radio buttons are used specifically with radio button groups, and check buttons are used specifically with check button groups. All UI components have three different states. Or four different states. There's check UI update, UI press, UI down, and UI release. These four will be checked once per frame, which I'll cover a bit more with the UI manager, and that will handle whether or not we call the push or release for each of the buttons, or how we handle updating the values that were given by the slider. So UI components have a dependency on their canvas. So UI components will be passed over to a canvas, which I'll showcase in the other spot. Oh, right down here. So UI receive which of these check calls they need to do from the canvas, which then receives it from the manager. That is the hierarchy of that. It goes UI gets the updates from the canvas, which then receives it from the manager. And then here are the functions for that. Both UI and the kitchen canvases, which I will showcase when I get to the canvases, all of them use registration, delayed registrations. So over here, they have the delayed registration request. So we have the requests for the canvas and the UI components. UI components register themselves to the canvas, and the canvas registers themselves to the UI manager. I blanked out for a second there. So here's the UI register. The UI register and UID register both use an attorney to do their proper pass-throughs. So here's the registry for canvas entry and exit, finding of the register and deregister class. So here's the UID register, which is right over here, part of the UI as the deregistration request. Next up is the canvas. So the UI canvases are a collection of UI components that will that is responsible for passing through what updates they need to do. So the UI canvas receives these updates from the manager, and they are part of an active list of canvases. Whatever the manager tells them to do, it will loop through all of their active UI components, pass in based on the mouse state, whether or not they need to do check press, check down, or check release. Whenever it gets a press check, it will end up calling both check press and check down, because whenever a mouse is pressed, it is also considered down. When it's checked down, then it will just do check UI down. Whenever it's released, it will do check UI release. Every frame, the canvas will be calling UI update, because that is an update to be done every frame. And then here are the functions for it. Next up is the UI registry and deregistry list. I'm just going to quickly go by them, because like I mentioned, the UI canvas has the standard registration. This registration will be using an attorney to call properly to the register and deregister for the UI manager, which will be right here. So the UI manager has some pass-throughs to the kitchen canvas, which includes initialize, remove, and getting and setting iterators for where it is inside its active list, as well as the update UI pass-through to tell the canvas to pass X criteria to its individual UI components. Initialize is where you submit entry for all your UI components, and remove is where you submit exit for all your UI components. So next up is the UI manager. It is part of the scene and is called once per frame as the last part of the update loop. It has a list of active canvases, and whenever the UI manager needs to process its elements, it will determine what the current mouse state is, as well as the mouse's position, pass that state and position through to the canvas, and then the canvas will use that state to figure out what check calls it needs to do with the UI. So the manager determines the mouse state and position, passes that data to the canvas. The canvas then decides how its UI components will react to that mouse state. Next up, we have button, which is one of the core classes for the UI components. This is where all the main button types derive from. So we have check buttons, held button, push buttons, and radio buttons. Held buttons and push buttons can be directly defined. Check buttons and radio buttons are attached to a group of them. So if I were to scroll down here, this is where we have a lot of setters and getters, and also defines what a button is. For buttons, they have two states. They have an up state and a down state. These are visually shown with different UI sprites. The user can redefine what these kitchen sprites are, but if the user redefines them, it is their responsibility to delete whatever they define them as. So if the user passes in their own up sprite, they better delete it when that UI component is deleted. The first button type is the check button. Check buttons are attached to a check button group, and they have a press state, a release state, and an active state. This is the only one that really has an active state because because they're within a group, they have an index, and whenever the group needs to find out what is active, it can look through to find out which indices they have for the active list. So all of the check button stuff here is mostly pass-throughs via an attorney to that specific check button group, and then the check button group will call the push, release, held, etc. So here's that attorney I mentioned. We have the push, active, release for the check buttons. Check button groups have a list of active and inactive check buttons, so there's also setting and getting iterators for rapid access. And then there's also rendering check buttons because the group will loop through all of its active buttons and render them. For the check button groups, these, as I mentioned, they have push, release, and checked functions that the user can overwrite. There are currently 8 check buttons that can be active in any given group. The check button groups have 2 lists, one for active check buttons and one for inactive check buttons. Inactive check buttons do not have the active call every frame. Active check buttons are part of the UI update where we call the checked overwrite. So for the check buttons groups, they have care for the check UI update and the check UI press. So whenever the canvas passes in a check UI press, that's where the check button will do its work. And when we see check UI update, it will do its work as well. So for check UI press, it will loop through all of its active members to see if a mouse button was successfully found. If the mouse successfully clicked on a check button, it will release it and push it to the inactive list and call release for that check button. So if check button 0 was released, it will call release 0 and move it to the inactive list. Alternatively, if check button 1 was pressed and it was already released, then it will call pushed 1 instead. During the update call, anything that is considered in the active list will have their associated check call. So since check button 1 was just pushed, it will call checked 1 every frame. Since check 0 was just released, this will no longer be called. Next up is radio buttons. Radio buttons have functions similarly to the check buttons in terms of them passing through indices. The main difference is that they don't have an active state that they need to worry about. All they need to care about is when they're pushed and when they're released, so they don't have that other pass-through. So we have radio buttons as pass-throughs via an attorney to get whatever the index is within the radio button group. There's also a type of radio button called a null radio button. This is used by the radio button group if the user did not define a radio button to start in the down state. This is because every time a radio button is pushed, a different radio button must be released. So this is just a no-op release to make sure that it doesn't crash by trying to release a null pointer. For the attorney, this is where we pass through the indices as well as the render call, because for, like I mentioned, with the check button group, radio button groups also are responsible for rendering all of their active radio buttons. So it'll loop through all their active radio buttons, update their positions to be vertically aligned, and then it will call the render call on it. For radio buttons, they have a push and release call for up to 8 buttons, similar to check button group. They care about only the check UI press, because whenever a radio button is pressed, the other one is automatically released. We don't care about the check UI release because of that. So for check UI press, it will loop through all of its active check buttons, all active radio buttons, excuse me. It will loop through all active radio buttons. When it finds a radio button that has been pressed, it will call pushed on that, and then release whatever was previously downed. And then it will break out because it found something to update. For both push and check buttons, only one button can be pushed at a time, so if something is ever found as push, you can just break out immediately. Next up, we have the held buttons. Held buttons are they care about check UI push, down, and release. Whenever a UI button is pushed, it will check to see if the mouse is over the button. If it is, it will set a flag to true. check GUI down will then check to see if that flag is true. Well, that flag is true, it will call the engine push, which will then allow the user-defined push to be called every frame. Whenever the user releases the mouse button, the check UI release will check for that flag that we determined. If that flag is considered released or considered true, it will call the engine release and set the flag to false because the button is back in the up state. Next up, we have the push button. Push buttons are using a strategy pattern to determine what to do during the check update stage. So for push buttons, there is release me and don't release me. During the update stage, if the current strategy is don't release me, nothing happens because you do not need to release the push button. If the current step is release me, then it will call through the attorney the engine release function because it needs to be released. So that is handled over here. Push button attorney. Push button attorney. So over here, this is where the release is called, and that will wrap around to the push engine release right here. Whenever the mouse button is pressed, it will check to see if the mouse is over the button. If it is, then it will call the engine pushed and update the strategy to be release me. If it's not over it, then nothing happens. Every update, like I mentioned, the given request is executed. If the request is don't release me, nothing happens. If the request is release me, then via the attorney, engine release will be called. Lastly, we have sliders. Sliders are composed of ticks, segments, and ends. The ends are the curved part that represent the boundaries of the slider. Segments are everything in between. The tick is the part that is updatable by the mouse inputs. Check UI, they care about check UI press, down, and release, and all of those function identically to how held buttons work, where when you press down, you check to see if the mouse is currently on the slider. If it is, you set a flag to true. While that flag is true, during the mouse down process, we will update the tick's position to be wherever that mouse is. With the exception that if the mouse ever moves off of the slider, we will clamp it to either the minimum groove or the maximum groove, depending on which direction the mouse is moving. And then on release, if that flag was set to true, we set the flag to false, and then we call the proper calculate. Sliders have two strategies to determine how they handle the release. There's either slider by groove or slider by percent. Slider by groove, whenever you release, it will clamp the tick position to be whatever the nearest groove is. Slider by percent will take whatever percentage of the slider is to the left and pass in that value, whereas slider groove passes in the groove that they were clamped to. So this strategy is executed via an attorney during the check UI release. Check UI percent will be called if the entry was done by percentage, and calculate groove will be called if the entry was submitted by groove. And then here are the two strategy. Here's the attorney. This is where the pass-through is done for either the groove strategy to call calculate groove, or for the slider strategy to call calculate percent. And that's it.